Hi, I'm Tom Hudson, and this is Coding for Beginners. In this video we're going to look at writing your very first programs using the Ruby programming language. And to do that, I'm going to use this website Repl.it, R-E-P-L.it. It's a website that lets you write and run code online, so you don't have to install things to your computer or go through complicated setup processes or anything like that. So when you launch the website in your web browser, it should look a little bit like this. I recommend signing up. It's a great website, but if you want to skip that, just scroll right down to the bottom to the list of languages down here and select the Ruby language. So we're just going to jump straight into writing some code so that we have something to talk about. So I'm just going to dismiss this settings panel and increase my text size slightly so you can read things a bit more clearly. And I'm going to write this code. Puts, P-U-T-S, and then in quotes, hello world. So this is somewhat of a traditional program for beginner programmers to write. And really it's made up of two things. The word puts, or put s, and then this piece of text enclosed in quotes. A programmer would call this piece of text a string. Now, when I first learned to write code, I got a bit confused when I was reading about strings and was thinking of actual pieces of string. But that's the wrong mental model to have. Really, it's a string of characters, like a string of bad decisions or something like that. So the word puts is a thing called a function call. And that is to say, it's a reference to a piece of code that somebody else wrote. It makes it do something. And I think of it as a little bit like being a verb or a doing word. If this were a recipe, it might be something like the word fry or mix or stir. And then this piece of text or this string is what we would call an argument or a parameter to that function. It's like the noun to the verb. For instance, if in a recipe you were asked to fry onions or mix a batter, the onions or the batter would be the argument or the parameter. So if I'm going to click this run button up here, and then over in the right hand side we should see it says hello world, and this is the output of our program. So we can write code here on the left hand side and we can see the results of it running on the right hand side. So let's be honest, this program is pretty boring, and I'm not just being flippant. I'm actually going to define levels of interestingness for you. So this program is boring because it does the same thing every time. It doesn't accept any kind of user input. It does nothing that I, as a programmer, haven't told it explicitly. In terms of functionality, I may as well have just opened up a Microsoft Word document and typed hello world. So let's make it do something a little bit more interesting. I'm going to change the text hello world to say, what is your name? And then below it, I'm going to write name equals gets, or get s. The s here stands for string, get string. And then I'm going to put one more line, that's another puts with quotes, and I'm going to say hello, comma, and then this funny little looking incantation here, a hash, a curly brace, the word name, and then a closing curly brace, and then an exclamation mark. So I'm going to run this, and we can see over here on the right hand side it says what is your name, but then it just sits there. What it's waiting for is for me to click on the right hand side, type my name, and then hit return. And we can see it says hello Tom. So let's look at what we did. So the word name here is actually completely arbitrary. I could have just mashed the keyboard and it would have kind of at least worked a little bit, but that's kind of silly. This thing here is what we would call a variable. And I think of variables as being a bit like boxes with labels on. You can put whatever you want in the box, but it makes sense to write an appropriate label for it so that you know what's inside. And in this case, the thing we're putting inside this variable is the input we get from the user. And we get that input using this special function called gets, or gets. And the reason this is special is that it does what we call returns a value. That is to say, it gives us some data back that we can use for things. And in this case, we use an equal sign to assign the value of name. So the way this line reads is get some input from the user in the form of a string, that is to say a piece of text, and put it into this variable called name that we've just created. The next line is quite similar to the very first one in that it's a call to puts, and we output some text, but we have this special little thing here, this hash and the curly braces and the word name. And what this is a signifier to Ruby that there's some work to do here. And in this case the work is very simple. It's just find the value of this name variable, that is to say almost look in the box and see what's inside it, and replace this whole section with it. It may sound kind of silly if you're new to programming, but this code is being interpreted one character at a time. Ruby is literally, on some level at least, looking at individual characters and figuring out whether it understands them. And it's not until it gets to this space here that it knows there's going to be some call to the puts function. Then as it starts to read the text, it sees a double quote, and it knows it's going to have to read through this until it reaches another double quote. But at some point it gets to the hash and the curly brace and realizes, oh, this isn't a normal, what we would call a literal string. There's some work to do here. I have to replace this section with the contents of this variable. So when we run the program, you might notice that there's a slight bug here. This exclamation mark is forced onto the next line. And it's a very minor bug, but this is such a simple program that really any bug is bad. So in order to see why this is happening, I want you to pay attention to what happens when you type your name. Now, I grew up using computers, and I somewhat instinctively, when I finish typing input, hit the return key, which is the right thing to do. But hitting the return key kind of has a dual purpose here. It's signifying that I have finished inputting data. But think about what happens when you hit the return key in an editor. It inserts a new line, right? And that's done by inserting an invisible character called a carriage return and a line feed. It's actually a pair of characters, but for our purposes we'll just think of it as one special invisible character that signifies a new line. So what's happening is, when I type my name and hit return, I'm inserting one of those invisible new line characters. And that's being stored in the name variable along with my name. And when it comes to output it, it's being outputted back out to the screen. There's an invisible character here, part of the name variable, which is forcing this exclamation mark to appear on the new line. One of the things I want to do with this series of videos is leave the bugs in. I've gone through a lot of tutorials online and found that they tend to take the approach of, oh, if you write this code, then it works. And I don't really like that approach, because I think the most difficult thing about programming is actually debugging. So we're going to leave the bugs in so that we can talk about how to solve the issues that they create and how the symptoms are manifested. So in order to solve this, I'm going to go back up to this line here where I have my gets, and I'm going to add something on the end. I'm going to add dot strip. I'm going to run my program again, put my name in, and we can see the problem is gone. It's fixed. So what we did was we added this dot strip thing here, and what this is a thing called a method. And they're very, very similar to function calls. Really, you can almost think of it as a different way to write the same thing. This is actually one of my least favorite things to explain, but I'll try my best. So, where a function call is like a verb, it's a thing you can do with something. For example, I could pick up my laptop, or I could throw my laptop, perhaps inadvisably. But my laptop, as a thing, also has actions it can perform itself. It can download music, or play YouTube videos, that kind of thing, launch websites, and they could be considered the methods of the laptop. And the way I would write those would be something like laptop.download music. So the way this line really reads is get a piece of text from the user, a string, and then call the strip method of that string. And what the strip method does is remove any invisible characters from both ends of the string. In this case, that would include spaces, and also these invisible new line characters that were causing us problems. So that's that problem solved. Everything's kind of working. But this program is still quite boring. And the reason it's boring is that although it now does something I have not specifically told it as a programmer, for me as a user, it's not telling me anything I didn't tell it. I know my name. I don't need a computer program to tell me. So let's add something else to this to make the program actually do some work. So after we've said hello, I'm going to add another puts to say, how old are you? And then we need another variable. I'm going to call this one age, and that's going to be gets again. And we know about that new line problem, so we're going to add the dot strip straight away. And then we have one more puts, and it's going to say, in 10 years you will be. Then we have the hash and the curly braces again. And in there I'm going to put age plus 10. I'm going to run my program. It's going to ask me what my name is. I'll say Tom. And I will be honest about my age on this occasion and say I'm 32. So we get an error. And the error says no implicit conversion of integer into string, and then some more letters and numbers and things, which we'll ignore for the minute. Other than to say this colon 11 here refers to line 11 in the left-hand side. That's where the error is, so that's where we should start looking. And what this is really saying is, right here, we're saying age plus 10, but these are two different types of data. When we got an age from the user, we used the gets or the getS function, which gives us a string or a piece of text. And it doesn't really make any sense to try and add a number to a piece of text. So what we need to do is be a bit more explicit and tell Ruby what type of data we want this to be. So back up on line 9 here where we get the age, I'm going to add one more thing onto the end. .to underscore I. And this is shorthand for to integer, which is this word that was in the error message over here, where an integer is another word for a whole number, like 4 or 5 or -3. So let's see if that fixed things. My name is Tom. I am 32. In 10 years you will be 42, which is maybe a slightly scary thought, but we won't dwell on that too long. So great, we've made the program more interesting, and we fixed another bug along the way. So this program is now more interesting from a programmer's perspective already, because it's doing things I as a programmer haven't specifically told it, but it's also doing things that are interesting for me as a user. At no point did I tell it that in 10 years I would be 42. That's something that it worked out for me. Now, yes, I can add 10 to numbers, and I'm sure you can do the same, but the fact that we added 10 to something is completely arbitrary. This could have been any calculation with any numbers that we inputted. With just these few things, you can write actually useful programs. You could write something, if there's a formula, for example, that you use often and can never remember, you could write a small program which prompted you for the various inputs, perform the calculation, and then outputted the result. But it's still missing something that would make it even more interesting, and that is logic. The way this program runs is a bit like a straight road. There's no turns to make or anything. It's the same path through the program every time. So let's change that. So at the end of the code, I'm going to write if age less than 18, and then I'm going to put the word end, and then I'm going to come back, and in between I'm going to hit the tab key to indent my cursor, and then I'm going to write puts lucky you, because being slightly older than many people, I'm a little bit jealous of all those young people. So let's run the program and see what happens. So my name is Tom, I'm 32, and we can see the result is exactly the same as it was before. But if I run the program again, and we just wait for Readability to catch up, run. My name is Tom. If I lie about my age and say I'm actually 16 and I'm young and full of energy, I get this extra little part at the bottom that says, lucky you. This thing we wrote here is called a conditional, and specifically an if statement. And its purpose is to ask a question, a yes or no question, or if we're going to be a bit more programmery about it, a true or false question. And if the answer is yes or true, we are going to run this piece of code between asking the question and the word end. And if the answer is no or false, we are not going to do anything in this case. So the question we are asking is the value of the age variable less than 18? If it is, output, lucky you. So this makes the program a bit less of a straight road and more like there's an optional turning partway along the road that we can take. But what would be even more useful would be if it was more of a fork in the road and we had two possible options. If the answer to this question is no, we want to be able to do something else. And else is the key word here. So I'm going to unindent my cursor, type the word else, and on the next line I'm going to indent again and say puts, oh, let's think of something not too disparaging to put. Oh, I can't think of anything. Well, let's just put, I'm sorry to hear that. And let's run the program again. Now, if I lie about my age and say I'm 16, I get the message, lucky you. If I'm a little bit more truthful and say I am 32, I will get 10 years and 42, and I'm sorry to hear that, which is, it's a little bit disparaging, but we'll leave it at that. So with this addition of logic, we can write truly interesting and truly useful programs. Conditionals are really a foundational piece of basically every interesting program that you interact with. The ability to ask questions and do different things based on the results is really, truly a fundamental part of programming. That's everything that all the code we're going to write for this video, but I want to draw your attention to a couple of things. One of which is that I indented these lines here. I pressed the tab character to indent my cursor. And that was actually optional. This program will work just fine if I don't do that. Really, this is a matter of style or a matter of taste, but however you want to put it. But the important thing is it's about readability. I want to make it really clear that this piece of code belongs to this conditional statement, and specifically for this first branch, if you like, the bit that will be executed if the answer to this question is yes or true. And this part belongs to the else section, the code that we're going to run in every other situation. One of the important things about programming is that you make your code readable, because programming, certainly in a professional context, is really a group activity. Very large and complicated programs are rarely written by one person. And really we write code primarily for humans to write, and only incidentally for computers to execute, which is a quote I stole, I believe, from Donald Knuth, who is a famous computer scientist. So not an original idea of mine. But it really is genuinely important that we write things in a way that is readable to humans, and that puts a minimal cognitive overhead on that task, because code can be difficult to understand at the best of times. And if we were to remove all of these line breaks and remove the indentation, suddenly it becomes much harder to follow the flow and the structure of the program. So that's very important. In the next video, we'll look at writing an actually more interesting program, a number guessing game. So I hope you got something out of that and you were able to follow along without too many problems. If you have questions, leave them in the comments and I'll do my best to answer. I'll see you next time.